Hello everyone. In my last video, I demonstrated step-by-step installation of Free5G core on bare metal Kubernetes cluster, where I talked about and ran through all the steps, starting from setting up the Ubuntu machine, then to the Kubernetes cluster, CNI installation, and finally the Free5G core installation, along with the UE testing. It was a long manual process which took us close to 2 hours. In this video, we'll see the power of infrastructure as a code tool, which in short we call it as IAC, and the automation. I created this Terraform configuration to build the complete Free5G core setup on the Azure Cloud. Now please take a note that we can utilize the modules to make the code neat and clean. However, for the viewer's better understanding, I'm using the separate resources from Azure provider on the Terraform. Now, to understand the connectivity, so there are several ways to implement the external network connectivities on Azure. For example, you can use the public IPs directly assigned on the VM snake, or you can use a load balancer on both the inbound and outbound connections. However, for this demo, I have utilized another option where the inbound connectivity is taken care by the load balancer and the outbound connectivity is taken care by the NAT gateway. So let's go through my Terraform configuration. Now, let me pull my Visual Studio Code. So this is my project folder, and let's start with the versions.tf file. So in this file, I have a Terraform block where I have mentioned the provider which I'm going to use and then the specific release what we're going to use for this demo. Next, we have the provider block where we can include the provider specific configuration. We can also have a completely different file such as the providers.tf file to keep the provider configuration completely separate. Next is the networks.tf file, which cover all the basic network related configuration. So in Azure, all the resources are configured under the resource group. Next we have is the Azure Virtual Network, Azure RM Virtual Network. With other cloud providers, so we call this as a VPC as well. Then I have two different subnet, which we are going to use for a two different NIC of my Azure VM. So these are the two different subnets, demo subnet 1 and demo subnet 2, and these are my two NICs. Next, we are going to create a network security group. This is to filter the traffic on the Azure network. Now the network security group that can be assigned either on the interface level or onto the subnet level. So for this demo, I am allowing all the inbound and outbound connection, which shouldn't be the case. These are the inbound and outbound connection, which shouldn't be the case actually for the production setup, where we should set up more granular filters. And finally, we are going to associate these network security group to each subnet. Next we have is the NAT gateway. So we are going to use the NAT gateway for the internet connectivity, and therefore we need a public IP. So here we're going to create a public IP, and this is the resource which we are going to use to create this public IP. Next, we have the NAT gateway resource, which definitely is going to create the NAT gateway itself. And then we are associating each subnet for this NAT gateway. So these are the subnets which are going to utilize this NAT gateway for the outbound connectivity. Next we have is the load balancer.tf file, which is primarily, so here in our case we are going to use a load balancer for the inbound connectivity. So if you know the general concept of the load balancers, where we have a virtual server which provides the virtual IP, and then the traffic received on this virtual IP is being forwarded or routed back towards the backend pools, and it uses the I rules in F5, and it uses the probe as well to test the health check of the pool member. The same concept actually applies for the all load balancers, similar in Azure as well. So first we are going to create this a public IP which is going to use as a virtual IP towards the external traffic, incoming traffic. Then we are going to create this load balancer itself, and we are assigning this public IP as the front end IP. Then we are going to create our backend pool, and this is the probe we are going to create. So we are going to probe the backend pool on the port 2022 for the SSH connectivity, just to check that the pools are working, pool members are working fine. So these are our inbound rules which you are going to see. So we are allowing our SSH connectivity and the web UI connectivity, which will be free or web UI. And then we are going to create our backend pool members. So we are utilizing the NIC interface to create this backend pool. So the next we have is the outputs.tf file. So if you look into the output.tf, here we have all the output values which we are going to see as an output once the the Terraform configuration is executed successfully. So these are the resources, some of the resources which we are going to need for our connectivity once the resources are completed successfully, such as the public IPs of the load balancer which we are going to use to log into those nodes. Then these are some of the other information what we are going to output as part of our configuration. So this can be customized based on the specific need. The next we have is the variables.tf file. So here we have all the resources. We have defined all the variables what we are going to use. You can see here the virtual network address as well. The CIDR that we're going to use here is 172.168.0.0/16 subnet CIDR. And then we are going to create two different subnet out of this CIDR. So these are the first two subnet available into the /24 mask, and then we have the tag what we are going to tag all the resources with the. So these are all the variables what we have configured here. Next we have is the main.tf file. So main.tf file is where we are creating our Free5GC virtual machine, and we are using all these resources which we have created from the previous files. So the first resource we are creating here is the storage account. This resource is being we are creating for the boot diagnostic and to access the console. The next is the one which we are creating is the Free5GC virtual machine. Here we are going to provide the size what we are going to use for the virtual machine, and then we are providing our SSH keys. We can create the SSH keys on the fly as well, and then we can utilize that in our configuration. But here I'm going to provide my SSH key which have already been configured on my Linux machine. Then I'm going to mention the image what I'm going to use for this creating this VM virtual machine, and then providing the storage account, associating the storage account what we created for the boot diagnostic as well. Then to configure this virtual machine with all the Free5GC dependencies and to create the Free5GC resources, I'm utilizing these provisioners, the remote and local exec provisioners. So I have created the scripts, and these scripts I'm going to put on this newly created virtual machine, and then I'm going to execute those onto the virtual machine. This is the local execute which will be running on my machine, and will be running this command to actually restart the VM as well. So this is just a very simple script which will actually provide us all the dependencies already been created on the virtual machine once the virtual machine is ready. So that's about my Terraform configuration. So now let's execute our Terraform configuration and build all the resources. Now please ensure you have the free credits available in your Azure account. Otherwise, executing this demo is gonna cost you and will appear on your bills. So let's start with the Terraform init. This is going to download all the required plugins to your .terraform folder. Since I've already executed this before, so all the plugins are already available on my local machine. Next, we are going to use the Terraform format just to ensure that the formatting of our code looks nice and neat. The next, we are going to run through the Terraform validate to ensure the So the validation is also successful. Finally, we're going to run through the plan. These are not the required steps if you just simply want to apply, but just going to demonstrate that these are all some of the commands which are available. So the Terraform plan is going to tell you what exactly it's going to do when it's going to run this script, but it's just like a dry run activity. So let's wait for the output. So it will tell you all the resources what it's going to create when we are going to apply this configuration into the Terraform. So these are all the resources. So you can see it's going to add these new 25 resources, nothing to change and nothing to destroy. So let's go ahead and let's create these resources. And we are going to give an auto approval, otherwise we need to provide the another input, yes, when we are going to prompt it. So let's apply these resources. So let's wait for this execution to start. Now this execution is gonna take some time, so it's going to take a few minutes to get completed. So in the meanwhile, I'm going to mute myself and will wait for these resources to get completed. So we can see now that the execution has been completed successfully, and these are all the resources which has been, all the 25 resources, these has been created successfully. And these are the output what we actually configured in the outputs.tf file. So this is the LB front-end IP configuration, and here we can see our public IPs assigned to load balancer, to the NAT gateway, and this is the resource group which we have created. So we can look into the Terraform straight. These are all the resources. If you want to look into the some specific, for example, if you want to look into this specific resource, we can. So here we can check this specific resource, which is load balancer public IP. This is the IP address and all the detail for this specific resource. So now let's log into our virtual machine and let's check all the resources as well. We can also check all the resources from Azure CLI as well, but for better visibility, let's log in and check on the Azure portal. So this is my portal. Let me just refresh all the resources. So this is the resource group which has been created. Under this resource group, you can see all the VMs and all the other resources which have been created. So this is the network security group. Check the topologies or the network space and all the details what is required. So this is the basic topologies of our virtual machine, and we can further detail and we can check a lot more information on the Azure portal. But first of all, let's try to log into our newly created virtual machine. Let's grab the IP address and let's log into the machine. So we are, as we mentioned earlier, that we're going to use for the inbound connection, we're going to use the load balancer. So let's grab the load balancer IP and let's log into the machine. This is the user what I've created. So this is my virtual machine. This is the newly created virtual machine on the Azure. So this is the name which we are given, the Free5G core, and this is the user what we have created. So let's log in here as well. Let's give the public IP of the load balancer. Goes here. Now let's check all the namespace, because as part of our script we have also created the namespaces. So we have created the 3 namespaces which is required for our Free5G core. You can see the control plane, access network, and the user plane. Let's check that there is nothing has been created so far. So now, since everything has been already been deployed, let's see. Let's create our user plane. Now we can run through this also as per the step, but as part of our script. But I mentioned this separately, so at least we know, okay, what we are doing as part of the Free5G core. So I'm going to deploy the user plane first. Now for all the detail of this parameter, you can refer my previous video where we actually gone through all the detailed step. So this is going to deploy our user plane. So we can simply check the so it's already up and running. Next, going to deploy the control plane. So let's check the so this is gonna take some time, a couple of minutes. So let's start the so it's first of all it's going to deploy the starting the MongoDB port, and then it's going to start the other ports like the NRF, and then after that it's going to start the all the other ports like EMF, SMF, and PCF, and SSF, UDM, UDR. So let's wait for these ports to be get deployed. In the meanwhile, let's log into our UPF. And let's configure the host, the name server as a Google IP as well. Again, you can check my previous video that why we are configuring this. Update the our Alpine Linux image on the UPF. And let's install the TCP dump. So we can see the TCP dump. It's running fine. It seems all the ports are up for the control plane. Yep, so all the ports are up and running. We can check the logs. Let's check the log for the EMF. So seems nice. So we are running the debug with the info, so that's why we can see the basic log. We can enable the debug if you want to see a bit more detail for them from the logging point of view. So EMF has been started and is listening on the port 38412 of this IP. Let's check the SMF as well. So we can see it's been server has been started, registration completed over the NRF. Then the PFCP association request was sent and been actually the response was received successfully and the association was completed. Now we need to create the UE on the web UI, so we need to actually do the port forwarding. So let's create another port. So let's open the port forwarding. grab the public IP. Okay, so the forwarding has been done. Let's log into our web UI. So we are going to use the same public IP, load balancer public IP, where we have allowed the access for the web UI as well, the inbound connection on the port 30500. So now we can see the user subscriber has been created, but it's not active. So now what we're going to do is we are going to create the access network. So this is going to create our Gnode B's simulation and the UE as well. Now, if you want to take the traces of the control plane, in the previous demo I actually explained how we can take the traces on the Kubernetes, and then we can actually copy those traces out, and we can look into all the control plane signaling of the UE, how the registration is happening, and how the PDU session being established in the 5G. So for the traces, you can look into my previous video. So here we're going to simply create the the UE. So let's create so this is going to create our new UE. Now let's check the status of the ports here. Okay, let's log into our UE. It's been the UE has been created. Let's wait for the registration to be completed. So we will see the tunnel on the UE pod. Okay, now you can see the tunnel has been created. So let's try to ping the internet resources, internet from this UE tunnel. Now you will see the tunnel has been created, and you can see the ping. So this is our UPF where we have started the TCP dump. So you can see that the package being actually received on the UPF GTP tunnel. Let's stop this the TCP dump. So we can see the package been received on the UPF GTP tunnel, and then it will be sent out on the S6 interface. But we are not getting the response back for these ping packets. Why? Because on Azure, the NAT gateway or the load balancer that doesn't allow the ICMP. So this is something actually been discussed recently as well. So here we can see the net not support. So they have, it's been actually specifically mentioned that the NAT gateway supports the TCP and UDP protocol, but ICMP isn't supported, and this is quite recently been discussed. So ICMP is not supported, but the internet connectivity is working fine. So therefore, to test the internet connectivity, we are going to use the curl requests. So that's why we have started the traces with the port 80 as well. So let's actually stop the ping for a while, and let's remove the ping for a while, and let's take the trace specifically on the port 80 and port 443. So let's log into one more. Also, in the meanwhile, just to see that now the UE is in the connected state. So you can see here the UE has been registered, and now it's in the connected state. So here you can see the UE is in the connected state. So this is the pulling the AMF information. You can check in the AMF log as well. This is the SUPI, which is the permanent identifier in the 5G. Here we have the 5G GUTI, and then the MCC MNC. The tag was being used. DNN, which is nothing but an APN in the 4G as well. So DNN is equivalent in 5G. Here we are going to use the access type is the 3GPP access type, and this is the service slice ID and this which has the two values SD SST and the SD. So you can see SST is the service slice type, which is 1, which is for EMBB, and then the service descriptor. So this is the PDU session this is the DNN internet which has been actually aligned, and this is the IP address which has been assigned, which is we can see on the UE as well. So now let's log into the UE and try to do the curl request. Also just to make sure, yep, these are in. Now let's run through that call request and see the packets. Now you can see the packet's been actually received. So here we can see is the packet was received on the UPF GTP tunnel. It's been sent out on the N6, and then it received the response back in on the N6 interface, and then sent the response back on the UPF GTP tunnel as well. So here you can see the response back, which is coming as 200 OK, so which means a successful response. Similarly on the port 8443, if you want to test, so we can simply run the other. So this website actually provide you the IP what you are going to use for the internet connectivity. So since we are going to use the NAT gateway for the external connectivity, we will see that this IP is going to, when we are running through this the website, it is going to provide you the NAT IP, which is your external NAT gateway IP. So again, this was executed, and you can see the traffic on the UPF going out and received on the GTP tunnel, being sent out on the N6, and we got the response back, and then we sent the response back to the UE. So here you can see the IP was been provided. So this is the IP, this is of the external interface, and you can see that this IP is same as what you have here for your NAT gateway. So we can see that the traffic is actually being sent out via the NAT gateway. So you have the inbound connectivity via the LB, and for the outbound connectivity through the NAT gateway. Now, so this conclude our free 5G core demonstration on the Azure. Now, if you want to, just make sure that you don't keep your resources running onto the portal, otherwise it's gonna again cost you if you don't have any Azure credit. So what we are going to do next is to simply destroy all the resources what we have created here, and that can be again done from the Terraform. So you can simply the auto approve, so it's going to destroy all the resources what we have created as part of this demo. So for the sake of it, we can log out from our, though that's not necessary, just for so it's going to remove and destroy all the resources. So here you can see this is going to destroy all these resources. Just similarly is created the plan, and then it's going to destroy all these resources. So here you can see nothing to add, nothing to change, and 25 to destroy, as we created the 25 resources earlier. So guys, I will highly recommend you to watch the previous video where we actually gone through a bit more detail on how we can actually deploy all these resources manually. This will give you a better understanding actually that what really goes under the hood. But this video is more focused towards the automation and the infrastructure as a core, that how to automate these kind of a task. So now we can see that destroy has been completed and all the 25 resources been destroyed. So if you'll check the state now, so you will see the state is completely empty. We can check the portal as well. If we check the resource group, now our demo resource group, Free5GC resource group is now deleted as well. So we can see now all the resources have been cleared. So this conclude our this demo, Free5GC demo on the Azure. In the next demos, we'll talk about how we can deploy it into the Kubernetes infrastructure on the AKS or GKE. The problem what I'm facing with the GKE is the current GKE releases is not supporting the multi CNI or the multiple network interfaces for the port. For the AKS, I am going through all the different CNI configurations. So AKS by default provide our the kubenet, which is the default CNI which is being implemented from the AKS. Then actually it has its own Azure CNI, which is the advanced networking CNI. Or we can simply utilize the Calico to actually provide the CNI plugins, and we can utilize the Calico on the AKS as well. So we're going to explore all the different options on the AKS. Now feel free to try the AKS as well. So thank you very much guys.